So today onwards, we are going to start the question series for power systems. So the first questions that can be asked from power systems, what is the structure of power systems, like the basic structure of power systems, how the components of power systems are connected on the top level, what are the components are there in power system, what is the single line diagram, and we will see all of these things. Okay, so if I talk about the power systems, basically a power system has mainly three components. Like a power system has mainly three component. It is basically first is generation, and this generation can be you can get the generation from fossil fuel based sources also, and not non-fossil fuel based resources also. Fossil fuels are nothing but the coal, gas, and diesels and all. Whereas the non fossil fuel based resources is something like you can get the electricity generation from nuclear power plant, solar, wind, and geothermal. And there are many, like there are many non-fossil fuel based resources. So there is generation, and this generation voltage level is since this generation is done by synchronous machines and other generators, so other even other renewable energy resources. So the generation voltage levels are not too high. It lies in between. You can say if I talk about synchronous generator only, so the generation can be up from 11 kV to 25 kV. It lies in between this range in case of synchronous generators, and for other renewable energy resources it varies accordingly. But as of now, I'm mentioning only for synchronous generator generation level. Okay, once you have the generations, then you have transmission also, because your generation part is far away from the load center, so there must be a connection in between the generation and the distribution, or you can say the load, so that can be linked through the transmission line. So the second part is transmission. Okay, and this transmission is basically it is done at high voltage level, and there are a few reasons why we do this high voltage transmission. Basically, I will maybe discuss in some other videos and all, but let me give you some brief idea. Like if you do this transmission at higher voltage level, in case of AC transmission only, then at higher voltage level, you will get more steady state stability limit of the system, and your transmission line losses will also decrease. So these are the main two reasons. Maybe mathematically I can discuss all these two reasons in some other video, but as of now you can just remember like what is the transmission line voltage level. It may vary from 220 kV to uh, 765 kV. Okay, and then comes distribution. Basically, in between transmission and distribution, there is one more there is one more section, that is something called sub transmission voltage level, or some sub transmission levels. So that I will discuss in single line diagram. But as if I broadly explain what are the things are available, or what are the basic components in power systems. So basically, first is generation, then second is transmission, then third is distribution. Uh, distribution and distribution can be of primary distribution and secondary distribution. Primary distribution is nothing but the distribution voltage level will be around 11 kV, uh, 11 kV for primary distribution. And for the secondary distribution, we have this 440 volt for three phase, and for single phase it can be 220 volt or 230 volt, like that. So from the generation to distribution, you have this transmission. We will see how the single line diagram and all look like. So uh, and these particular generations are far away from the load center, or you can say from the distribution. Now, let me tell you something more. Like if I talk about India, In India, basically we have these five regional grids, and first is the northern grid, then second is eastern grid, western grid, southern grid, and northeastern grid. Northeastern grid, okay. And these are the regional grids, and these grids are also interconnected, and this all five, if you connect, it form a synchronously national grid. So this all are connected through tie lines. So you can say all are in synchronism, you can sort of you can say. So and they are connected through transmission lines. These five grids are interconnected through transmission lines, okay. So these are the five grids, and it form a national grid once you connect through tie lines uh, or transmission lines. Let's now move on to the kind of single line diagram of the power systems. So what you will be having, first of all, you will be having generator. Let's say, for example, I have synchronous generator here, and this voltage level, as I mentioned, it can be from 11 kV to 25 kV, right? And then you have to step up transformer, and this voltage level can vary from 220 kV to 765 kV, okay. This is something we call transmission level, transmission line, and these transmission lines are also connected to other systems, or you can say other lines. uh, like as I mentioned, like these five regional grids are also interconnected. So if this is your one grid, so this will be interconnected with some other grid. So it is maybe it is a tie line that is connected to other system, okay, as they are interconnected. And because they are interconnected, they gives lots of benefits for us, but maybe I can discuss all of these things later. But as of now, let's focus on the single line diagram, how we are getting electricity from generation to load center, okay. So this is the transmission, you can say transmission level. So it is your transmission. Now we have sub transmission level also. We do the step down now, okay. And this voltage level varies from it is basically it is from 33 kV to sometimes it varies up to 132 kV, okay. This is your sub transmission level. It is required because some of the customers or some of the big consumers, they need this kind of voltage level. So you can mention like this voltage level is for large consumers, okay. Now you have this. Now again you do the step down. Basically, let me write down the step up or step down also here. um, it is step up, it is step up transformer, step up, okay. It is step down, okay. Now you have again step down here, step down. Now you have distribution will start, and you have two kind of distribution. You have primary distribution and you have secondary distribution. So let's say uh, here the voltage level will be 11 kV, 11 kV, and maybe this voltage is going to some industry, this 11 kV, industry and all, let's say, and the voltage level that we get in our uh, home or in our locality, again there will be step down voltage, step down distribution transformer. Okay, so again it is a step down transformer, step down. So it is step down transformer, and here the voltage level will be 440 to 230 or 220 volt. Okay, 440 volt, or for three phase system it will be 440, and for single phase it 220 volt or 230 volt like that, or 230, like 230 volt, it varies. Okay, so these are the load centers, loads, the actual the consumers, the local loads, you can say. So this is the last one, is basically it is done by the distribution transformers. It is a distribution transformer. mm, it is a distribution transformer, and this is also a distribution transformer, and these are the power transformers. Okay, these are the power transformers. There are few difference in between distribution transformer and power transformer that we can discuss later, but I hope this single line diagram is pretty clear to all of you. Let me explain you one more time. So basically you have this generation, let's say it is a synchronous generator, and it is these locations are the, like, they are far away from the load. If this is my load, they'll be far away from the loads, because the synchronous generator can be driven by hydropower plant and all. So they are not, like, you can say they are not nearby your home and all, so they will be far away. So you have to step up the voltage. As I mentioned, what are the reasons to step up the voltage? If you step up the voltage in case of AC, you will be having two advantages. The For a given power flow, your current level will decrease, and subsequently your transmission line losses and all will also decrease. Okay, and one more reason is, if you increase the voltage level, then that voltage level will increase the steady state stability limit. I will discuss all of these things in another video, but for example, just for now you can just remember these 2 points, and you have this transmission level after that. So that voltage can vary from 220 kV to 765 kV, and then you have this step down transformer, and this is something we call sub transmission voltage level, and it is vary from 33 kV to 132 kV. Now distribution comes. Distribution has two things: primary distribution and secondary distribution. So this part is basically part of distribution, you can say. So it has primary distribution and secondary distribution, and like the primary distribution gives power to some industry, or you can say medium large consumers and all, you can say. And the secondary distribution comes to our home. Okay, and this particular one, uh, this tie line connected to other system, you can think like these tie lines are basically connecting these grids all together. Okay, so they are interconnected systems, so they formulate a mesh network, and they share power in between themselves, you can say. And tie lines, if they are interconnected in nature, in transmission level, so there are many advantages. If I talk about, like, there can be a shortage of power in one grid, so you can borrow power from another grid, and there are many advantages for that. Okay, you can operate your regional grids at minimum cost and all. So there are many phenomena and all. So we can discuss all these things later. But I hope this video is pretty clear. If you have any doubt, you can ask me in the comment section. Thank you.